Okay, so question 26. What will be the major product of the reaction of 1 mole of propine with each of the following reagents? So 1 mole of propine. This 1 mole bit is very, very important, and we'll use that for the other sub-questions for 36. So there are actually quite a few sub-questions for 36, but again, I'm just going to do a few just to kind of get you going in the right direction. So propine. This is propine, propine, propine. So meth, eth, prop for 3, and then the one propine is understood, so we have our triple bond here. And it really doesn't matter, it would be a symmetrical molecule, so no matter how you draw this propine, you'd be right. So what we're going to do is add HBr, and the important bit is that we're only adding 1 mole. So if you think back to a couple of the previous problems that we've done, we can either add 1 or 2 moles. If you only add 1 moles or 1 mole of HBr, you only have 1 reduction step. So and you get an alkene. If you add multiple moles or an excess of HBr, you can have that excess react with the resulting alkene, and you can get multiple brominations going on. So the important bit here is that you have a 1-to-1 equivalency. So for every 1 molecule of the propine, you have 1 mole of HBr. And so what you have to remember here is that you have 2 different possibilities for regiochemistry. You can either put the H on this orange, and I'm just going to go ahead and label each one of these as orange, or you can put, for this first example, the H on the blue. I'm just going to label blue for all these guys. And so we have to remember that if you assume that this is going through some kind of partial vanillic carbocation intermediate, which just go ahead and think of it that way because it's easier to go through the rationale in that way. You can say, well, if you have a partial positive here, after you get rid of the triple bond, you'll have a secondary vanillic versus primary vanillic. Of the two, secondary vanillic is going to be slightly more stable, so having the plus or partial plus on this orange carbon is going to be more stable. So that means that we're going to put our hydrogen on this blue carbon, and we're going to put a partial plus or plus, depending on how you want to look at it, on this orange carbon. And the Br minus that you get from the initial electrophilic addition, that's going to end up adding to this carbon right here. Okay, so what we're going to have is final product is going to be this guy, double bond because it's only 1 mole, and we're going to end up getting Br right there. Okay, and then obviously we'll have 2 hydrogens right here instead of 1. Okay, so that's with 1 mole of propine, 1 mole of HBr. Okay, so for the second question, sub-question C, what we have again is propine and Br2. Again, 1 mole to 1 mole. And what's really important is that they're telling you the solvent is DCM or dichloromethane and not water or some other kind of solvent that could act as a nucleophile. So no kind of halohydrogen potential here. Okay, so what we're going to do is we're going to end up taking our triple bond. It's going to end up getting reduced to the double bond. And we're going to have 2 bromines being added just like we've talked about with double bond. Same thing applies here with a triple. So in this case we have 2 bromine atoms being attached. Each of them came from that original molecule of bromine. And again, if we did this again, if we added multiple equivalents, you could have multiple additions. Alright, so sub-question F, you have, again, triple bond, 1 mole, and you have disalmylborane, or if you want, if we've talked about 9-BBN, either one of these are sterically encumbered boron reagents that can do hydroboration. And then after this, we're going to do our oxidation with the hydrogen peroxide and OH. The thing to remember here is that we're doing anti-mark. So anti-mark. Okay. And what we're going to have is 1, 2, 3 carbons. So 1, 2, 3 carbons. And we know we're going to have anti-mark, so the hydroxy is going to end up adding to that blue carbon. And we're going from a triple to a double. We're going to have that enol being formed. And again, we have enol keto tautomerization, and we're going to end up getting our aldehyde. Okay. So again, notice that we haven't added or subtracted any carbons. We're just doing basically a hydroxy addition that ends up tautomerizing. And again, this is a very, very small amount, very minor, major.